The Orbital Test Satellite, OTS, launched on the 12th of May 1978, is the first ESA telecommunications satellite. OTS is a pre-operational satellite paving the way for a European space telecommunications system that will cover Europe and the Mediterranean basin. The decision to construct OTS was made in 1973. Under the prime contractor, British Aerospace Dynamics Group, United Kingdom, the MESH Consortium, Matra France, ERNO Germany, Saab Sweden, Air Italia Italy, grouped firms in 10 European countries for the development of the spacecraft and the payload. AEG Telefunken Germany, Thomson CSF France for the development of the repeater, and Selenia Italy for the development of the antennas. OTS is a six-sided satellite whose total liftoff mass, including the apogee motor, is 865 kilograms, and whose mass in geostationary orbit is 444 kilograms. Dimensions are height 2.39 meters, including antennas, and width 2.13 meters. With the solar panels deployed, it has a span of 9.26 meters. The electrical energy required for operating the satellite is provided by a solar array consisting of two deployable panels fixed on the sides of the satellite. The power delivered is 700 watts at the start of life in orbit. In the eclipse phase, power is supplied by a set of two batteries. 6 parabolic antennas, each one equipped for frequency reuse by cross-polarization, will provide transmission and reception of telecommunications. OTS operates in the 11 and 14 gigahertz frequency bands. The use of these frequencies avoids interference with the ground networks, generally operating in the 4 and 6 gigahertz bands. The traveling wave tube amplifiers developed for this program were the first in the world to use the 12 gigahertz frequency for space telecommunications. The thermal control subsystem must provide a satisfactory ambient temperature for all equipment. The satellite's thermal control is essentially passive. Sheets cut to size, super insulation. The only active devices being the radiators, which provide a minimum temperature for certain critical equipment items. By the spring of 1977, the flight model integration was completed. To reach this decisive stage, various prototypes had been built. These were subjected throughout their development to rigorous tests and adjustments. Propagation tests in an anechoic chamber. Calibration of sensors. Spin tests, thermal, electrical, and vibration tests. centrifugal tests to check the future behavior of the satellite during the acceleration phases of the launch. The apogee motor is an American solid motor with a mass of 430 kilograms. Its function is to increase the velocity of the satellite in transfer orbit for the purpose of injection into geostationary orbit. In parallel with the manufacture of the satellite itself, the control and reception station was being built at Fucino, east of Rome. The assembly of the 19-meter antenna is but one of the tasks relating to an extremely complex and sophisticated element. On completion of the station, transmission-reception compatibility tests between the satellite's payload and the station were carried out. For this purpose, a payload model was transported to the summit of Monte Magnola above Fucino in order to simulate the position of OTS in orbit. The first flight model is mounted on its American launcher. The launch takes place on the 13th of September, 1977. But 54 seconds after ignition, the Delta launcher explodes and the satellite is destroyed.
This is the test review board for the OTS-2 satellite.
The launch was covered by insurance.
Its main aim
Integration of another flight model could be started at once.
which have occurred since we released the satellite for environmental testing at TRB-1.
In March 1978, the second OTS flight model is shipped to Cape Canaveral. It is given a final checkout before being mounted on the launcher. The deployment of the solar panels is given a final check. The thermal protection is permanently put into position. The mylar sheets are attached by special adhesives designed to resist the enormous temperature differences in space during the satellite's 3-year life. The satellite is positioned on the upper stage of the launcher. The satellite and upper stage are brought to the top of the launch tower. The fairing is put into position to protect the satellite as it passes through the Earth's atmosphere. The launch tower is withdrawn. Everything is ready. After final checks by engineers and technicians from ESA and industry, the project controllers can authorize the launch.
3, 2, 1, 0.
The 12th of May, 22 hours 59 minutes GMT, 18 hours 59 minutes local time, OTS is launched. The launcher first puts the satellite on an elliptical transfer orbit. The positioning of the satellite is achieved by a series of telecommand maneuvers using telemetry. At the end of the fourth apogee of the transfer orbit, ESOC, the European Space Operations Center in Germany, orders the apogee motor to be fired. Its thrust will enable the elliptical transfer orbit to be transformed into a geosynchronous circular orbit. The order to deploy the solar panels is given, and a series of maneuvers will enable the satellite to be stabilized and positioned at 10 degrees east over Gabon on the equator. The OTS mission, based on needs defined by the European PTT administrations and the European Broadcasting Union, is to prepare the European Space Communication System, ECS. The OTS antennas cover the whole of Europe and the Mediterranean basin. Spot beam covers Western Europe, where 80% of telephone communications take place. The satellite power has been concentrated on this beam in order to provide point-to-point links. Eurobeam A is used for the transmission of multiple destination television signals and covers an area extending from the Azores to Tel Aviv and Reykjavik to North Africa. Eurobeam B is used mainly for propagation experiments and narrowband transmissions. About 50 university institutes and European telecommunications entities are taking part in these tests by using terminals with antennas of approximately 3 meters diameter. OTS, designed to function for 3 years, is a forerunner to the European Space Communication System. 4 countries have already opened ground stations equipped with transmission antennas of between 15 and 19 meters diameter. They are the following. Fucino in Italy, which also provides satellite control. Bercenay-en-Othe, near Troyes in France. Goonhilly Downs in Cornwall, Great Britain. Usingen near Frankfurt in Germany. A network comprising up to 25 stations of this type will be used with the first of a series of operational ECS satellites. European Space Communication System satellites derived from OTS and constructed by the same firms. The first launch will take place late in 1981. These satellites will serve to establish, through the PTT administrations, long-distance communications and the broadcast of Eurovision programs.